Problem A. E to the sixth is equal to x to the n over n factorial, which is equal to 1 plus x squared over 2 plus x cubed over 6. To create e raised to the x to the sixth, all we need to do is erase the x and replace it with x to the sixth. And that applies to the series, so we have the summation. Instead of x, we write x to the sixth raised to the nth over n factorial. Looking to the right, we can also just replace the polynomial with x to the sixth. So we have a 1, plus instead of writing x, we write x to the sixth, plus instead of writing x squared, we write x to the sixth squared over 2. And lastly, instead of writing x cubed, we write x to the sixth cubed over 6. And of course, we always want to simplify. So you get 1 plus x to the sixth. X to the sixth squared is x to the 12th, so that's x to the 12th over 2. X to the sixth to the third is x to the 18th over 6. What this process allows us to do is integrate something that's impossible to do by hand. So here we have an integral from 0 to 0.1 of e to the x to the sixth dx, and we can't integrate that by hand. So instead, we can integrate the polynomial that we discovered in problem 1. So we take the integral from 0 to 0.1 of 1 plus x to the sixth plus x to the 12th over 2 plus x to the 18th over 6, and we can integrate this by hand by using a power rule. So we take the integral of a 1, that's x. Integral of x to the sixth is x to the 7th over 7. Integral of x to the 12th over 2 is x to the 13th over 26. X to the 18th over 6 turns into x to the 19th over 114. Plug in our values from 0 to 0.1, and we get a value of approximately 0.1. In problem 4, we use our calculator to see what we get by using the integration function in the calculator, and we also get 0.1. And it's interesting to note that the calculator does use a summation. It's much more complex than what we just developed, but it is very, very similar.